Okay, in this video tutorial, I'm going to try to do a couple of things. One is show you how to use Jupyter Notebook to make your data analysis really easy. Second is use Python to clean up the output that you get from ERPLab into a more readable file, and then at the same time create range scale data that many of us use to do topographic analyses. So I'm going to assume that you have some familiarity with EEGLab and ERPLab, and here I have the measurement tool up in ERPLab, and as you can see, I have all of my subjects here on the left-hand side, each one of those ERPs, and I'm taking some measurements, in this case 500 to 800 milliseconds, and a time window, and computing the mean, amplitude, and what we're going to do is have that dumped out into this file that's going to go into a particular directory. Now, one quick thing, I'm outputting this data in long format. That means basically you have voltage on each line of the data file, and I'll show you what that looks like in just a second. But you're going to have voltages in each row of the data file. Now, the only thing you have to do special here is make sure you include the bin label, and I use the bin label to know what condition the ERPs are. Once you do that, you'll export your data file out of ERPLab. You'll get something that looks like this. Let me close some windows and move some things over. So you'll get a data file that kind of looks like this. And I've saved it here as a text file. And here's the value. Those are microvolts, right? Here's your channel index. This is automatically output from ERPLab. You have your channel label. You have your bin index. You have your bin label. The bin label is important because it tells you like what condition it is. And then you have your ERP set, which ultimately amounts to a subject number. So a couple things to point out here. First of all, this is a tab separated data file. This doesn't work well with a lot of editors, and reading it in for analysis can be problematic. That's why I'm going to clean it up using Python. So what we're going to do is we're going to clean this up and make it comma separated file or CSV file. And you'll notice a couple things. It's tab delimited, but there's also some extra spaces in here. You can particularly see it here with these electrodes. So we're going to strip those off. The other thing is you'll notice that the bin labels contain the various conditions. So this is a prime type. So this was a prime with orthographically similar non-words. And this was a hit, so an old item called old. And if you scroll down, we have the same prime type here, orthographically similar non-words, and we have correct rejections, right? And that continues, and the prime type will change. And so we have hits, we have correct rejections, and we have different prime types. What we're going to do is use Python to separate those out and create variables that we can use for analysis. And then you'll also notice that here we have subject number 132. I number my subject number starting with 100, and then we have 131, and so on. The code here is just for the study. The PDISF is just for the code for the study itself. And then I have an underscore in ERPs, and that lets me know easily I can spot ERP files amongst the sea of other EEGLab files that often populate a directory. So that's what we're working with. And then, so let me close this all out so that we can get this cleared up and out of the way. And so what we're going to use is we're going to use Jupyter Notebook. So this is Jupyter Notebook. I have a separate video that shows you how to install it. This is a wonderful thing to use. You can create a new notebook. Now, the cool thing is I have Python 3 is set up here. And then you can also install R to run in Jupyter Notebook. So it's really easy just to switch back and forth. And what Jupyter Notebook does is it creates savable notebook files that runs code. So it can run Python and it can run R code and give you output, real-time dynamic output in the window itself. And I'll show you a couple of examples of that, as we go through this. So this is code we're running Python, as you can see up here. We're running Python. And what it's going to do is it's going to first load up that file that we were just looking at. So this is just the path for that file that we're looking at. Notice that we have forward slashes here. That makes it easier for Python to sort of read that, even if you're working. I am working on a Windows computer, but forward slashes here in the file name itself. Then we're going to specify an output file name. So all I changed here is we're going to make it a CSV file as the output, and then we're going to make a scaled file name, so it's going to have the same name, but then I have underscored scaled Those are three different file types that we're going to be working with. Now I have 29 electrodes in my array. You can change yours to match. So I'll go through each of these individual commands so you can sort of see what they do. And what you're going to have is you're going to have a directory. So here's my directory, and I've already run this, so you can see that all of the CSV files are in there. But what you would have is you would just have your text files, your output for these different time intervals that I have here. So I have 4 different time intervals here for this particular study: 140 to 160 milliseconds, 240 to 260, then 300 to 500, and 500 to 800 milliseconds. So I have 4 different text files here that are all output from ERPLab that I'm going to convert. So the first thing we're going to do is we're going to create a data frame. So this is a Python phenomena, also true in R, but data frames are great. They hold data and they allow you to work with them. So it's going to read in that data file that we had, and you notice it's reading in the input file name, and the separator is tab. So it's going to read those in. And when we read them in, though, there's a couple of things that we need to account for. So the first thing is we need to strip off extra spaces in the variable names, the column names. So this first command is going to do that. So it's going to take that. So then we're going to strip off the spaces from the columns of data themselves. So like when I showed you the channel label, you could see that there were some spaces in there. And these commands will do this. It'll just strip off any spaces. Then we're going to rename some of these things. So I don't like the name value. Instead, I'm going to use volts for that. That's just easier for me to track it. Now, one little caveat here is I use variable names with all capital letters. I did this because I kept getting sick of getting errors that were case sensitive. So I just went to all capital letters for all my variables, and it makes it a lot easier for me. And I don't get, at least if code's not running, I know it's not because it's a case sensitive thing that's causing a problem. So I just do volts, and then we're going to change channel label to electrode, a little bit simpler to use and understand in your data files, and you can sort of scroll through those. And I'm going to show you some of the output files here when we're done. So now next thing we need to do is we need to split the bin label variable. So remember where I showed you it had a prime and it had an item type. So I'm going to create 2 of these variables. So I'm going to call it prime and I'm going to call it item type. And we're going to strip the bin label basically on the separator. In this case, it was the underscore. Let me go back to that file so you can sort of see it. So here I've opened it up for you just so you can sort of, this is a different text file, but it's the same concept. So the first part of this is going to be the prime. So the prime is the OS non-word, or that code for OS non-word. And then the underscore is the hit. So what we're going to do is we're going to split this bin label into 2 variables, one called the prime on the left, item type called hit on the right. That's the level of it. That's what we're doing with this bit of Python code. It'll do it magically for you. Then we're going to do the same thing. Oh, let me go back to that. Then we're going to do the same thing with the ERP set. So we're going to search through and we're going to split off this, and we're going to just get rid of the underscore ERPs. And what we're going to do is we're going to mine this so that we can get the subject number. So we're going to strip off the code name, and we're going to be left with the subject number, and we have a subject identifier in our data set. So we're just calling it a file name and then something to throw away, which is a discard. And we're going to, again, split that. That's the underscore ERPs is what we're throwing away. We're not using that. We're going to split that by the underscore. So then I'm keeping a file or a variable called project. If you were analyzing data across projects, you might want to keep this. I'm not going to use this in this example right now, but we're going to strip it out of the file name variable that I created, and it's going to be the first 5 characters or so. And then sub ID is going to be the remaining characters of that file name variable. And so then all we have to do now, sub ID right now is a string, so now we have to make it a numeric variable so that we can analyze it. So it'll change like the string 132 into a value of 132, right? Now you'll notice that I have some things commented out here. The nice thing about Jupyter Notebook is you can pull these back in, and if you just type df, you're going to see your data frame. It'll just appear below the text. Now this is going to completely run, but play around with Jupyter Notebook or learn how Jupyter Notebook works. It's really nice. It gives you output like down here. This is output from when I ran this before, and it'll tell you, gives you output that's happening as you're running it. So you can check your code, you can sort of see what it's doing, you can look at variables, you can see variable values, whatever you want. It's really nice. So then what we're going to do is we're going to write some columns. So then we're going to clean up our data file, and our data file is going to have a column of data for the sub ID, the electrode, the prime type, the item type, and then the voltage, our dependent variable, the microvoltage, right? And then we're going to write it to a CSV file, and then we're going to have a nice little statement that just says, hey, the clean data has been saved, and gives the output file name, and you'll see it down here. So the data file has been cleaned and saved to this, so I know that it got to that point in the code and that it actually created that data file. So let's look at that data file that got cleaned up from the other version. So I'm going to open it up, and because it's a CSV file, the default is going to be an Excel file, and I'll show you what that looks like. So this is the default CSV file. So here's our cleaned up data file, right? So we have our subject identifier, we have our 132, right? We have our electrodes, and notice there's no spaces, it's nicely cleaned up. Then we have our prime, then we have our item type, and you can see that the item types change, right? And then we have our voltage, right? So this is a nice CSV file, very easy to read into R or Jamovi or any of the other analysis programs that you want to use. This is perfect data ready to go to be read in and analyzed, okay? Now, the other thing that we're going to do in this code is, because we're already in and we've already created this file, we can create range scale data. So basically, range scale data, what you do for each condition is you find the highest value, you find the lowest value, then you're just going to subtract the lowest value and divide by the difference in the two. So you can check out that McCarthy and Wood paper if you want to learn more about why you do that and how you actually do that. I'm going to go over that fairly quickly here, but we're going to create a variable called scale data, or list actually called scale data. And all I've done here is I've created the data frame 1. That's the one I'm going to be working with, and I'm going to make it equal to that original data frame, and I'm just selecting out the stuff that I want from that, because there's extra junk in there. If you remember, there's like channel index number and stuff like that I'm not going to use. So I'm just selecting the stuff that I want, popping it into this virtual data frame that I'm calling df1, and then we're going to find the length of this, because this is going to be important because you're going to loop through your data. And each condition is basically the number of electrodes that you have. And so we're going to find, first of all, what's the length of our data frame, how many rows do we have in our data frame, and then we're going to loop through that. So if you notice, we're going to go in this first loop here, we're going to go through from 0 to the data frame length, and we're going to do that in steps of the number of electrodes. So basically, it'll skip every 29 electrodes in this data set for those loops, so the number of iterations matches your data frame size. That's why we want to do this. Then what we're going to do is we're going to use the pandas to slice up our data. So we're going to slice it up, and we're going to slice it up into chunks of, in this case, 29 electrodes. And then we're going to find the max voltage in that 29 electrodes, minimum voltage in that 29 electrodes, and then we're going to create a scaled version. So basically, using that equation that I said before, we're going to take the voltage, we're going to subtract it from the minimum, we're going to subtract the minimum voltage from it, and we're going to divide by the difference and create it, or put it in this new variable called scaled within this. And then what we're doing is we're just appending, so we're creating like a new data frame that each time takes those 29 electrodes and adds them in with new scale data. And we're going to loop through our entire data set. And then what we'll do is we'll create a final data frame and write that out to a file, and then give us a message that says that it's done that. And so what happens is we end up with our data file, and I'm opening it up here in Excel so you can sort of see that. When you have these commands, is you'll now have scale data. So you still have sub ID, electrode, prime, item, all the stuff is preserved, but now it's like scaled values. And you can see 1 is the most positive electrode. In this case was FP1, so it has a value of 1. Everything else has a decimal number except for the lowest, which would be 0, because when you subtract off the 0 or the lowest value and divide by the difference, you're going to get 0. And that's going to be true for that condition. And then it starts all over again for the next condition. The next condition is scaled to its maximum and minimum, etc. And so now we have this scaled data file, and I have another version which this does it for one data file. It's pretty easy in here. I can just sort of show you. It's pretty easy to change the Python code if you have multiple files. And all you're going to do is you're going to create lists. What the difference would be here is lists for all of your input files, output files, and scaled files, and then created a variable for how many times you're going to loop through this, and then you're just going to loop through that and do this how many ever times. So I had 4 files that I was converting, so it ends up being 4 different values. And what you end up with in that particular situation is in your directory, you will end up with the CSV file and then the scaled CSV file for each one of your time intervals. Well, that's why my directory looks like this in this particular point. And once you've done that, you're now ready to transition. And in another video tutorial, I'll show you how to analyze your data in R using Jupyter Notebook. It would be really easy. We could start a new, actually we could close this file, and we could start a new R and write text or write code script to then read in these files and analyze them. And it's trivially easy to sort of switch over and do that. And when you do that, you really see the power of Jupyter Notebook, because you can see the output of the R output in Jupyter Notebook. And I'll show you how to do that in the next video. Also look in the description for other resources like where to find these files and to find snippets of that code, etc. Hope you found this helpful.